And essentially what it is, it's a device which allows you to combine the action and reaction components of a torque system in such a manner that the resulting torques from both the action and the reaction are combined and applied to the same load. And there is a rather interesting increase in overall efficiency when you make use of this principle. Now, the machine that you're going to see here is designed in such a way that the motor which is propelling it can be utilized in two different modes. One is when the rotor alone is turning the load, which is what you're going to see first, and the other is with the combined action as previously stated. So with that introduction out of the way, this is the machine itself, which is nothing more than a little frame supporting a specially designed motor, and has a jack shaft and some pulleys and two gears. The device you see in front of you here is a pony brake, a miniature little pony brake to measure the torque, and we will take the RPM readings separately with a handheld unit that records the speed. The input power is going to be monitored by a Yokogawa series power analyzer, which is about 0.25% accurate, and so we should be getting some pretty good numbers. So the first thing we're going to do is we've got the pony brake arm loaded, preloaded, to produce a torque on the system of 6 inch-pounds. And with that torque in place, we'll run the motor first in the normal mode configuration, and we'll record the numbers. And then we'll run it in the counter rotation mode, and we'll record the numbers. And then we'll draw some conclusions from the results. Ready?
Yeah.
Start at any time.
Go ahead. Okay. And what's your RPM?
219.2.
Okay, go ahead and stop it so you can set up for the next.
7.5.
Okay, he's got it set up for the counter rotation. You can see in the back that he has it set up so that
Shafts combined.
the shafts are combined to the one shaft. And we're going to run the test now with this. Right now, with the same setup, it's like 7.5 foot-pounds. Inch-pounds, excuse me, inch-pounds of torque. Okay, Jim's going to go ahead and start at any time, Jim.
Are you ready?
Yep. Okay. Okay.
RPM reading is 437.7.
Okay, we're all stop.
And that means that we've enjoyed a ratio of improvement of 2.97 to 1 by simply rearranging the geometry of the drive system and making no other changes. So that's a significant effect, and the insinuation of utilizing this technology is that if you started out with a motor which was already designed for a higher efficiency, that you would probably get system efficiencies very close to or over unity, at least if it behaves the same way as it's doing now. So that's our preliminary report.
Okay, thanks, Jim.
Sure.
You can just turn me back on now. Can you do it? Turn me back on now? All right, good. Okay, I'm back on again. I'm not very loud. You had to turn it down there. All right, so if you got it back up again there, all right. Now, this right here is the counter rotation device. Now, what we did here is we have the rotor in the middle with the motors on it, and the motors, if you look here, you can see the motors are turning a belt. The belt is then applying torque to the center rotation here, and it's turning the rotor around. Now, the motors are supposed to be going this way while it rotates that way. What happened in the design of this is we had two cooks in the kitchen. We had Carini there, who was 80 years old, and we had a very ambitious engineer here that was working with him, who was trying to say that it wasn't rotating or counter-rotating, and he got Carini so doggone confused that actually this thing got built in a manner that it doesn't really counter-rotate. It's like as this goes around, the motors are going the same way that the whole thing is going around. So what we did was we decided that it was a bad idea to use the belts, and we went out and had this baby made right here. It's a gear. So it's a stationary internal gear. We made a stationary internal gear that we can put right in here and put it right up against this metal plate. So a stationary gear sets against the metal plate like that on the other side. And then through this stationary gear we have 4 pinions. The pinions are connected to motors, and the pinions would be going, the motor would be going the exact opposite. So the motor rotates this way as it rotates that way around it. Now that's counter rotation. So actually what we did was we went out and we paid a lot of money and rushed the job and got all this made, knowing that we had this meeting here. And we went back to our machine shop to take this apart and put it all on here and run it counter rotation for you today to prove to you we can do here exactly the same thing we did on the film there, which is pretty obvious. But our machine shop had a power failure. So in Butler we had a power failure and our machine shop went down. So without a machine shop, it was kind of hard 2 days before, or a day before this, to put it all together and get it to happen. So you have to have a little imagination with me. We're going to counter-rotate it. We're going to run it, but it won't be counter-rotated. So it isn't going to do the same thing that's on the film. And if you want to see it do it, you have to come back on Saturday, because Monday we go to our machine shop, we take the parts we got, we build them, we put them all together, move everything in, which is about a 1.5 day job, and you'll be able to come and see it. But you already got the concept, and you already know how the concept goes, and you see the over unity. So we're just going to run this now so you can get an idea of a unit that would be on your house. This is what would come to your house. It would sit here and spin around, and you're going to hear the noise that it makes in just a minute. Okay, we ready to run this? We're going to take, you see over here we got 3 car batteries, 12-volt batteries. We're going to start it on one 12-volt battery, and it's going to start whipping through the air. And then we'll engage a second 12-volt battery, and you'll see it goes quite a bit better. We also are going to put a load on it then with this little bitty generator here that can only produce about 1 kilowatt of electricity. That's all the size is. And it'll produce the electricity over here while it's running. But remember, this is not counter rotation. This is rotation because we screwed up, okay? I mean, we made a mistake. Now, I didn't make the mistake. It was the guys in the machine shop that made the mistake. I want you to understand that. Right? Thank you very much. Because you know I don't make mistakes, right? All right, anyway. Hey, buddy, don't stand close to me. You're going to get zapped by a thunderbolt. All right, so anyway, we're going to run it for you anyway so you can get the idea. This is what would go on your house for a seed unit contract. This is all we bring, nothing else. We set it down outside of your house. It will take an electrician about 3 hours to install the whole thing, start to finish. And that's it. You could even put it inside anywhere that you want to have it, and then you're going to hear the noise that it makes as it runs. Go ahead. Okay, so then it just sit there and run. Now you hear all that noise? Sounds kind of horrendous, doesn't it? Let me get this microphone over here. That's going to just drive you crazy at your house. Okay, we got it going. Let's just kick in a second one. Go ahead, it's okay. You can take a shot of that, sure. Okay, now it's on the second mode. Now it's really whipping out. You'd never go at RPMs over this because anything over that you'd already be applying to the load on your generator, running all the lights and making the light. Okay, so there it is going. Now when you want to kick in the lights? You want to go to 3? Okay, he's going to kick in the third one now. Okay, it's kind of whipping out there, isn't it? Now that one's really, really going. But we would have, by the way, it'd be counter rotation, we would have loaded it before we ever got to that level. So that one right there is a kilowatt of electricity. You want to get another one? Okay, that's about all that one would do the way it is now, and it's not counter rotation. Yeah, you're tempted, aren't you? Nah, you're overloading it too much. Okay, so we are overrunning the generator. This would all be very stable, and it really wouldn't make noise as it's running out there and it's cooling your house. But I'll tell you, on those hot summer days, this is the place to stand, right here. Just don't have a tie on. Okay, tell you what, let it run there for a minute. I want this man for sure to get a copy of film of that. All right, Jim, you got it? You got everything you need? Right, me next to it like this.
There's 3 cycles of its rotation. Our 6-cylinder with opposing crank powers all 12 magnets each revolution. That means we have a 12-to-3 ratio above anything that a gasoline engine would perform. This standard golf cart is running approximately 12 miles an hour on our improved 1-horsepower flywheel motor. Most similar carts utilize a 3 to 5 horsepower motor in order to attain the same speed. The car is a geoprism equipped with our 5 horsepower flywheel motor. We have run this car on the street at 40 to 42 miles per hour using only 2 12-volt batteries, 24 volt, 9 amp, 2,160 watts. Actually 138 watts less than a 3 horsepower motor.
Even if it's a small advantage, it's going to be something that's welcomed by all drag race drivers.
Well, we had a big head fire coming through the palmettos. It was really, 15-foot flames, some hot fire. We let it get up to the edge, and I went along behind it, and it was burned halfway through a palmetto patch. And normally with water, you can't stop it. Well, I hit it once. It was about 125 GPM on the nozzle. I hit it once. That was it. No rekindle. It was out. We kept going. It was really amazing.
Billing showed us 2 shacks side by side, one made out of geobond, the other standard materials.
Information only. Burn exercise is underway at this time.
With the Kansas City Fire Department standing by, both buildings were doused with fuel and set on fire. Within minutes, the shack made out of regular materials is on fire. The geobond house, not only is it not burning, you can actually put your hand on it.
Be careful, Vern.
Oh, it is right over here, over here. It's unbearably hot. And this
is perfectly cool.
Geobond may just be an idea whose time has come. Unlike conventional building materials, it won't burn. Unlike asbestos, it won't cause cancer. And if geobond does catch fire, commercially speaking, if it doesn't all
power, I can go up if I wish. Right on up. And I can pull the stick back and actually track backwards. Yes. And dump the nose forward. If I want to come down, I power back. Come down. And by pulling back off the stick slightly, holding here, coming up to full power. And here to about 30 mile an hour. I can move the stick around a lot, showing you the control work. And I'll come back around again.
Controlled conditions. Toxic compounds are combined with agents that promote detoxifying reactions. Now, over the last 12 years, Harry and Jean have concocted over 800 different recipes, and by recipes I mean mixtures of these solid wastes with liquid waste to make over 800 different end products. And they tell me that they expect to go on coming up with new recipes for many years to come. In a mixer, the pulverized solid waste is combined with the treated liquid waste mixture. After the solid and liquid wastes are mixed, polymer components are added. The wet pulp is then transferred to a form, extruder, or other shaping device. Pressure needed is mechanically applied. Uncontained, the polymers will expand in volume 25 times. Take a look at that reaction here.
These particular kind of products. Okay, if you can look or feel, if you put your hand over it, you can see we have what we're after. We have the heat, we have the expansion, and the only thing left is something that gets hard fast.
additional pressure is created by the expansion potential. Up to 50 tons of pressure can be achieved. The amount of pressure created varies with the desired density of the end product, which can range from 10 pounds to 100 pounds per cubic foot. Through chemical combinations, heat and pressure, a wide range of molecular rearrangements occur. All living organisms present in the waste, such as bacteria and fungi, are unable to survive in the high temperatures and pressures of the process. The end product is sterile, durable, non-toxic, and can be fire retardant and moisture-proof if desired. This is how the Hydromex process fabricates a limitless array of resellable building and construction materials, with no polluting emissions of any kind released and no unused byproducts.
A sort of high-tech coffee table.
Just look at pump, that's all it is. Just a pump. You can hear that one. You even pump here.
It's so simple.
That's the whole machine.
Where are you going now?
That's the whole machine.
That's it.
That's it.
Where's that go? Show me where that goes.
We're right here. Can I lift that? Yeah.
Yeah.
Yeah, that's it. There's nothing here. Just water and flotation.
And as that goes up and down?
Well, that goes up and down. That's where the wave does that for you.
Yeah.
The wave does that for you.
And it causes water pressure to build up inside?
Yeah. And you can go to any pressure. The big one can operate probably right around 1,000 psi.
And then you send that water pressure ashore in a pipe, Lieutenant?
Yeah, you send it to some kind of line.
Yeah.
And use it to make fresh water, for aquaculture, for generating electricity. It's like, I'll give you an example. Say you have a motor in your car, or wherever. I see the car, everybody knows car, right? And that motor will run forever. You never gas it up, you never grease it, you never put no oil in it, it don't make no noise, it don't make no fume. It don't cost you anything, but that shaft is turning all the time, forever. You'll find a way to plug a generator on it, you'll find a way to use an osmosis system, make fresh water out of the ocean, you'll find a way to pump water for your aquaculture, or whatever energy you need. If you got a machine shop, you want to turn some big equipment, that shaft don't cost you nothing. Another simple example is the faucet in your kitchen. You got, say, I don't know, 40 psi, most places, 50 psi. If you could open that faucet and it'll run forever, you never pay for the water. You never pay for the pumping or nothing. All you have to do is put a little water motor on it and then furnish the heat, the light, your fresh water, furnish everything for nothing. That's what it is. But Mother Nature does it for you.
Look, I don't mean this question to sound rude, but if you're so smart, why aren't you rich?
That's a darn good question. I was rich. I done it backward. Most people, they get smart and they want to get rich. I got rich first. Then being smart made me poor. So now I got to reverse that.
You said you had sex.
Now, this is the Waveberg in the local storm with wind up to 80 kilometers an hour. As you can see, It's riding tremendous waves. These are huge waves. This would compare for 150 footer, the equivalent to a tycoon of some kind. And there is no ill effect on the Waveberg. Hard to get steady here. This is Mother Nature in all its fury.
America. Few know, however, that bottled water is currently less regulated than municipal water. Legally accepted sources for bottled water may include wells, springs, and even tap water. In fact, the only thing you can be sure of when you purchase bottled water is that you're getting water in a bottle. If not serviced at proper intervals, home filtering systems, such as carbon and reverse osmosis systems, can become breeding grounds for bacteria and viruses. They can also be very costly and wasteful. For example, to generate 3 gallons of water each day, a reverse osmosis system can waste between 25 and 60 gallons a day. In nature, water is evaporated and drawn into the clouds, condensed as rain, and falls back to Earth. Instead of removing contaminants from the water, nature removes the water from the contaminant. The process filters the air, then collects the water, requiring no complicated plumbing. While producing drinking water from the air around us.
The best way to purify water is the way.
Okay, we're at Universal City Walk in Hollywood, and we're talking to people.
Back up away a little bit. Right there, beautiful. Okay, turn it around. Okay. Aluminum and the slag that came off the steel. Similar, but much more powerful than a thermite reaction. Apparently, you say that this is impossible with, the only way to do it is with this flame. With Brown's gas.
We have this reaction also with titanium.
You can have this reaction with titanium?
Titanium and what was this, nickel or titanium?
Titanium and aluminum also.
But we also have nickel.
Oh yes, nickel also.
Okay, now this is the Tork amplifier. This is a very, very, very interesting device that operates on open-ended geometry. I'm sorry for the tape here. We lost the audio on this, so I'm going to have to narrate this for you. This is Jim Murray. He's demonstrating this with a flexible shaft. Now he's also dialing up right now, putting power into it, and so he has a meter that's measuring the amount of power that is turning a rotating flexible shaft. Now the flexible shaft, if you notice, is turning this device that is built at a 3-to-1 ratio. So it's a 3-to-1 ratio, and it's turning it. Now he's got a man from the crowd named Thomas, believe it or not. We called him Doubting Thomas. He was doubting everything we did, so we had Thomas come up and check all of the meters and all the devices. And Murray is now applying electricity with a meter that can measure exactly the amount of electricity going in. And we'll have Thomas come over now and take a look at it and confirm that we also have a metering device that is measuring the foot-pounds of torque. There's a lever that is 12 inches long. That 12-inch long lever will get a foot-pound. In other words, be 1 foot long, so 1 pound of force exerted on a foot-long lever is a foot-pound of force. And so they're measuring now the amount of foot-pounds of torque that are on it. I can't see any meters, and so I can't give you the exact number of foot-pounds of torque that we were getting. But now Jim is going back over to the device that is measuring the input of electricity and proving that, you know, what the input of electricity is. It is also being confirmed by our Doubting Thomas that is indeed the amount of electricity that is going into that device. And so they're both concurring on that, and he's setting it and saying, yes, that's exactly the amount of electricity put in. Now, he has just, I believe, shut it off. And so we had test number 1, so many foot-pounds of torque at a particular RPM, and so that would measure the power or the horsepower, the mechanical energy, and we measured an exact amount of electricity. Now he has done this on the flexible shaft, which he is now removing, and by the way, as he's pointing out, this center shaft in the middle is a ratio of 3-to-1. That length that it's going around in circumference in open-ended geometry is 3 times the circumference that it normally would be just turning on the shaft. And so he's now removing the flexible shaft, and they can drive this directly on the shaft. So they've got a benchmark of something to compare this to, where they can compare an orange to an orange, because they have the RPMs constant, they have the amount of energy going in, and they have the foot-pounds of torque on the end. Now, Doubting Thomas is examining the shaft and looking for any hidden wires or anything in it. I'm talking to him there and making sure that he's satisfied with everything. Then we're going to hook this up to drive it directly. So we're now going to drive the motor directly off of the driver, and we bring the scale back over, and we set the scale down so that we can measure the amount of pounds of pressure that are being exerted on the scale. And since the lever is 1 foot long, 12 inches long, then we would be able to measure that in foot-pounds. And so we now have got a comparison. We're going to now turn it back on and see how much electricity it takes to get it back to the same amount of foot-pounds of torque. And so when we turn it on to apply the pressure to get the foot-pounds of torque, he's got Mr. Doubting Thomas coming to look and to make sure that we're doing everything right, and we've got the proper proper measurement on the torque meter. And there we do. We've got the same torque that we had before, but now we look at the amount of electricity that's doing it, and we have a major dramatic drastic difference between the amount of electricity that is being used in this particular case to do it. It can't even get the amount of foot-pounds of torque that we had before. It's confirmed. I don't remember the numbers. I wish I did remember these numbers, but I can tell you as an eyewitness that the ratio, this torque amplifier always doubles the torque of the mechanical device. It always doubles the torque. So when you use the same amount of electricity, you get twice the amount of torque or foot-pounds of pressure with the same RPMs that you were pulling it before. And so it always doubles the torque, and so the amplification is always 2 to 1. Always.